Welcome to day 2 of our mini unit of review from Unit 10 from last year, our trig graphing unit. Homework will be page 10, so the last page in this mini packet. So first one that we have, using our Pythagorean identity of sine squared plus cos squared equals 1. Remember, really what that is sine x in parentheses squared plus cos x in parentheses squared equals 1. How it's written there is just the common notation of how it's seen. So replace your sign with the 0.27, square it and subtract it over, and then to undo the square, do the square root of both sides. Now normally when you do a square root, you would need a plus minus. The reason they told us quadrant 1 is from our ASTC, all trig functions are positive in that first quadrant. So therefore it's the positive 0.962 and change. Tangent is always sine divided by cosine. And the reason for that is tangent is always O over A. And if you do sine, which is O over H, divided by cosine, which is A over H, and did a keep change flip, that's O over H times H over A. The H's wipe out, and it gives you O over A, which is the same as tangent. So if we divide the sine amount they told us in the question, 0.27, divided by what we just got for cos, and then round to the nearest hundredth, you get 0.28. All right, in our next one, first do your period. Period equals 2 pi divided by the frequency. Frequency here is 2, we get pi. So you wanted to put 4 tick marks. The fourth mark was a pi. The middle one was half that, pi divided by 2. Then half that for the first one, pi divided by 4. And then count by that, 1 pi over 4, 2 pi over 4. So the third one is 3 pi over 4. Put in, based on the plus 1 at the end, your dotted line for the wrap line at 1. We have a cosine graph, so you're starting 2 below. So the first point is 2 below the wrap line, then wrap line, maximum, wrap line, back to the minimum. And then our shift, if we're adding to x, you shift it left. So we want to go pi over 2 to the left. Based on our tick marks, pi over 2 is 2 tick marks. So we move everything 2 tick marks to the left, and that's where our final graph comes in. And the last one, do period equals 2 pi divided by that frequency of 1/4. We get 8 pi. So you do 4 tick marks, the fourth one being 8 pi. Halfway there, the second one is 4 pi. Half of 4 pi is 2 pi. So count by that. 2 pi, 4 pi, 6 pi for the third mark. Minus 3 on the end would lead us to draw our wrap line, dotted line at -3. Sine starts on the line. So your first point is right on the wrap line on the y-axis. It's a positive sign, so we go up 2 to the maximum, back to the wrap line, down 2 to the minimum, back to the wrap line. And then our horizontal shift, we have minus pi over 2, so we're going, minus 2 pi, so we're going 2 pi to the right. Based on our grid, that is 1 tick mark. So move every point 1 tick mark to the right, and we get the graph that's shown there. Today we're going to do 2 more graphing examples, and then we will go the reverse. We'll be given the graph and have to write the equation, and then we'll look at one word problem that involves trig graphs. So we're going to start out, we'll draw our XY axis. Notice our horizontal shift is a plus. When you add to x, you shift it left. So when we draw in our y-axis, we want to make sure that we leave some room to be able to shift it to the left. We don't want to go right on the edge. We're going to put in our 4 tick marks. And we'll find our period. Period is always equal to 2 pi divided by the frequency. The frequency is what's in front of the x. If there's a phase shift, meaning a shift left or right, that'll be out in front of the parenthesis. So we'll put the 1/4 in for the frequency. If you do a keep change flip, that's really 2 pi times 4 over 1. So we get 8 pi for that period. So 8 pi will be our 4th tick mark. Halfway there will be 4 pi. Half of that is 2 pi. And now count by 2 pi's to get the third one. 2 pi, 4 pi, 6 pi for this one. We need to make sure we label some type of scale on our y-axis. We'll just go by ones. Our wrap line, we're at -2. So let's put a dotted line in at -2. Cosine starts off of the wrap line. Because we have -2 in front of the cosine, that means we'll start 2 below the wrap line. So the first point we plot is always somewhere on the y-axis. Cosine again is off the wrap line, in this case 2 below. At our next tick mark value, we'll be on the wrap line. We just went minimum to wrap line, so the next point should be at the maximum, which will now be 2 above the wrap line. We are now going back to wrap line and then back to 2 below. But don't sketch in your curve yet because we have to do our shift. We're adding to x, so we shift it left, so we're going 2 pi to the left. For us, 2 pi is 1 tick mark, or you can think of it as 2 boxes on our grid. So every point is going to move 2 boxes, or in other words, 1 tick mark, and then we can sketch that in. I think I mentioned this last class, but I like to use a little different symbol than the dot when drawing that other one, especially when you don't have different colors, because sometimes they might land on top of the original ones. It just helps me to see the difference between them. So over on the right, our maximum value is that highest y value, which would be 0. Our minimum is that lowest y value, which would be -4. Period is what we labeled that 4th tick mark, and we calculated in the blue. That was 8 pi. Our vertical shift is where the wrap line was. It shifted down to -2. The phase shift is how we shifted left or right. So you could either say -2 pi, or you could say left 2 pi, and that would be okay as well. So vertical shift, I should say, you could have said down 2, and that would have been acceptable as well. Or you could say -2. Our wrap line is just that horizontal line equation where we put the dotted line, so y equals -2. Now we only drew one cycle of this cosine graph, but sine and cosine graphs actually go forever to the left and forever to the right. They just repeat that same cycle. So actually their domain is all real numbers. So you can either write all real numbers, or the symbol for all real numbers is a capital R with a double vertical line. And then our range, we go as low as -4 and as high as 0. Range is y's, so we could write that in one of two ways. We could do -4 less than or equal to y less than or equal to 0. I want to draw your attention to the fact that both of those inequality signs are opening towards the biggest of those numbers. They should be going the same direction and towards the big numbers. So that's one option. You could have also used square brackets because we had equal to's. So those two things I just wrote for the range, you don't need both of them, you would just need one of the two. All right, we'll look at one more graphing example. Can't remember if I changed this in the packet or not. If not, we're gonna graph this just for one cycle. So similar to what we've done for the other ones. Notice we don't have in parentheses an x and then stuff added or subtracted, so there's no shift left or right here. So because of that, we can go ahead and just draw our y-axis right on the edge of the graph. And we'll do our 4 equally spaced out tick marks. We'll begin by finding our period, which is equal to 2 pi divided by the frequency. Frequency is always what is in front of the x. So we'll have period equals 2 pi divided by 1/2. So we'll keep the pi, but you could do 2 divided by 1/2 in your calculator, and you get 4 pi for your period. So that's what the 4th tick mark will be labeled. The middle one will be half of that, so 2 pi. First one will be half of that, so 1 pi. And then just count by that first tick mark amount to get the third one. 1 pi, 2 pi, so 3 pi. Next comes our wrap line. Before we put that in, we should put some type of scale on our y-axis. So we'll just go by ones. Wrap line is happening at -1. So we'll put in a dotted line at -1. And sine starts on the line. So sine starts on your wrap line. So our y-axis point will be right on the wrap line. And we have an amplitude of 3, and we have a positive. So our next point should be 3 above the wrap line at our tick mark. Then we'll come back to the wrap line. We'll go 3 below the wrap line, and we'll go back to the wrap line. We said there was no shift left and right, so just draw that in now with a nice smooth curve. If we go to the next page, we're going to work in reverse, and we're going to find the equation of each of these. So start from the point that's on the y-axis, and we'll draw in one cycle. So we always plotted 5 points. So there's 1, 2, 3, 4, 5. So our one cycle is going from 0 to 2 pi. So if period is always equal to 2 pi over frequency, what we just found was our period. We found the length of the cycle. So we got 2 pi equals 2 pi over f. Well, the only way for the right side to be 2 pi is if we're dividing by 1. So frequency is just 1. We'll draw in our wrap line. If the highest is 4 and the lowest is 4, right in the middle is going to just be the y-axis. So what that tells us is we're not going to have anything added or subtracted on the end. So we're going to have y equals, let's leave a little space. Our first point was on the wrap line, meaning we have a sine. And we found that our frequency was 1. I just want to point out, they have the x-axis labeled as theta. So when we write our equation in this case, we would just want to use theta as opposed to x to be consistent with what the graph is showing. And we've got a sine graph. We went upwards first, so we'll have a positive number in front. Notice it went up to 4, so we'll have 4 out front. All right, going to the one to the right of that, we'll start with our point on the y-axis. Then we should have 5 total points to figure out our cycle. So we'll go to the minimum point, back to the middle, maximum point, and then back to the middle. So based on our scale, this spot here is 3 pi. So if period equals 2 pi over frequency, if period is 3 pi, we can put the 3 pi over 1 and cross multiply. 1 times 2 pi is 2 pi, and then we'll have 3 pi times f. We're going to divide both sides by 3 pi. So on the right we'll have f. The pi's wipe out, and you get 2/3. Our first point was on the wrap line. I guess we should specify the wrap line is right in between the +2 and -2 max and min. So our first point is on the wrap line, meaning we have a sine graph. So again, let's leave a little space in front. We'll have sine, and we just found our frequency was 2/3, so we'll have 2/3 theta. Nothing added on the end because our wrap line was just at the y-axis. And then out front, this time we went downwards first, and we went down 2. So we're going to put -2 out front. Moving down to the bottom, we'll start with our point that's on the y-axis. We want 5 total points. So we'll go middle, maximum, middle, back to minimum. Our period, notice, is 2 pi. So we actually just did an example of that one. Up above in the top left question, we had the period was 2 pi as well. Notice the frequency was 1. So we know this frequency is going to be 1 as well. If we hadn't just done that, we would have had to multiply it out and everything. If we draw in our wrap line, right in between the max and the min happens to be the y-axis again, so we will not be adding or subtracting anything on the end. Notice that y-axis point is off of the wrap line, so we're dealing with a cosine here, and we'll have 1 theta. And then out front, we are starting 1 below the wrap line, so we should have a -1 out front. One last, writing the equation one. We'll start with our point on the y-axis, point in the middle, minimum, point in the middle, maximum. That cycle ends at pi. So we'll do period equals 2 pi over frequency. We'll put pi in for that period. We'll put pi over 1 and cross multiply. So we'll have 2 pi equals pi f. We'll divide both sides by pi. And we get f is 2. So we've got y equals, our wrap line should be right in between the max and min, which happens to be the y-axis again here, so we're not adding or subtracting anything on the end. Our first point there is off the wrap line, so we're dealing with a cos. We found our frequency to be 2, so we'll have cos 2 theta. Our first point was 4 above the wrap line, so keep in mind we're recognizing our scale. It's only 2 boxes, but it's labeled that was 4 above, so we'll have +4 out front. All right, one last question. We're going to look at this video. We'll look at a word problem. So a pendulum, so think like a grandfather clock, the thing that swings back and forth in a clock, very sinusoidally. So you probably haven't seen that word sinusoidally before. So that's just a general term, meaning it might be a sine graph or it might be a cosine graph. So sinusoidally is just some periodic repeated motion. And it's varying from 12 feet to 2 feet away from the wall every 12 seconds. We're going to sketch the distance d from the wall over a 1-minute interval, time t, assume t equals 0 corresponds to when the pendulum is furthest from the wall. So in other words, t equals 0 is going to be the 12 feet. So let's make an xy axis, and we'll make a really long x-axis, or I guess it's a t-axis in this case. So we're going to do our t in seconds, and this will be our d-axis, which is in feet, our distance. And let's put a tick mark up high. That's going to be 12. And then they said the closest we're ever going to be is 2, so let's put a tick mark to label that. And then the other thing we'll need to know is where the wrap line is. Well, the wrap line is going to be directly in between those two, so we'll average them. So if you do 2 plus 12 divided by 2, that'll give you 14 divided by 2, or in other words, 7. So let's also put a tick mark in the middle, and let's label that 7. At the 7, we're going to put a dotted line that goes the full length of our thing, because that'll be our wrap line. And it said it should go from 12 to 2 every, where did it say that? 12 seconds. So let's put a mark on here for 12 seconds. We're starting at 12, and it should go to 2 at the 12 seconds mark. But that's going from a max to a min. So we must, in between, hit the wrap line. So in between 0 and 12 would just be 6 seconds. and let's put our point there on the wrap line. What this gives us now is our scale that we're going to jump by on the x-axis. We're going to go every 6 seconds. So next we'll have 18, then we'll have 24, then we'll have 30. And they asked us to graph for the first minute, so we're going to have to go out to 60 seconds. So we'll have 36, 42, 48, 54, and 60. So when plotting, we've gone maximum, wrap line, minimum. So next we should go back to the wrap line. Then we're up to the maximum, back to the wrap line, back to the minimum. Back to the wrap line, up to the maximum, back to the wrap line, and down to the minimum. And now we'll sketch that in with a nice smooth curve. And that gives us a visual representation of how far the pendulum is from the wall at any time since the start of our scenario. So in part B, we want to write a equation. Just note, instead of y, we have capital D, and instead of x or theta, we have t. So we're going to start off with D equals, because our first point is off the wrap line, we're going to be dealing with a cos. So let's leave a little room out front and we'll put cos. I'm going to go off to the side so that we can figure out what our frequency is. If we find our 5 points, we start at 0 and finish at 24 right here. So therefore our period is just 24. We'll put that 24 over 1 and cross multiply. We get 2 pi equals 24f. Divide both sides by 24. So the pi stays on top, and think of 2 24ths as a fraction, what it reduces to. You can divide them both by 2, so you get 1/12. So you can either write 1 pi over 12, or because the 1 multiplying by 1 doesn't do anything, you can just write it as pi over 12 if you want. And that's our frequency. So that'll go right next to our variable. So we'll have pi over 12t. Our wrap line should go on the end, so we're going to have a +7 at the end. And then out front, our first point is 5 above the wrap line. So therefore, we should have a +5 in front of our cosine. All right, that is it for this video. Any time left in the period. First, you can be working on the homework. If you finish the homework, then you can be working on any missing homework assignments that you have. Have a great rest of your day.